Hey, good morning. Welcome to an episode of This Historic Home. Today we're going to be doing some great work down in the basement. We're going to do several footings for the upshoring the existing beams. In those days they thought they could span 28 feet clear span without any kind of thought of deflection or fatigue. And so over 220 some odd years it's got a little sway back to it, actually to the tune of 2¼ inches in the 28 feet. So I made up several footings yesterday, and today, a little afternoon, we're going to actually pour those footings. Let me see if you can see these footings down here. These concrete formwork. We've got rebar here. There's number 5 rebar each way, about 18 inches each. It's going to go mid-span in the 24 by 24 inch form. And why I made those 18 inches is what you have to realize is that this is a basement. It's wet. It's earth formed. It was hand dug in the late 1700s. So late 1700s, and so we've got an issue with clear cover, and clear cover is actually the distance between the outside of the form. Clear cover is the distance between the outside of the form and the rebar. So the rebar needs to be at least 3 inches in this particular case in wet. I know in the south where it's close to the ocean, the sea breeze, actually the sea air infiltrates the concrete rebar, and as a result, once it swells, it expands, and then it blows out the side of the concrete. And that's why they have a lot of concrete restoration work down in Florida on the balconies and such, right next to the ocean. But in any event, here you've got the similar scenario, although it's not salt water. It's water infiltration from the basement. It's all earth formed, and you'll see. I'll take you down there now, and we'll take it and see what we're going to do to get this rectified and set up the forms and pour this. Hopefully, a little afternoon today, and then let it set for a week or so, and then we'll be able to put up our temporary shore posts with some elevation jacks. And I've got two 50-ton, you can see here, 50-ton floor jacks that will be able to raise the floor up little by little. You can't do it over extreme quick time, because it's going to be it'll break something, so you have to do it in graduation. That's why I have these shore jacks that will turn it maybe once a week. I'll have somebody come in and turn it once a week and raise this floor up eventually. Then we'll be able to go to the second floor and do the same thing there, but we need a good solid foundation for to jack the second floor up. Same deflection. It's got 2¼ inches in the 20 some odd feet, 28 feet, and so we need to use the floor base as the first floor as a foundation to jack the second floor up. It's got quite a bit of sway back to it, and so we'll take that out though. It'll take some time, but you can't fix it overnight after a house has been sitting here for 200 some odd years. And I'm not thinking about the people building it, not at all thinking about, you get a timber that's 12 by 12, it spans 28 some odd feet. They say, oh yeah, it's gonna. We don't think about deflection, they don't think about fatigue, but even the weight, its own weight after time, it'll deflect and go down. So we're going to fix that. Okay, here we go, down into the basement. And hopefully the light will come up and you'll be able to see what we've got here. And that's the actual rock wall. Somebody at one point had painted them white, I guess to brighten it up down here. Not that it makes much difference. So, and this is the actual dry set foundation. I don't know how well you can see this in the camera, but this is the dry set foundation for the chimney up on top. We have 2 giant opposing chimneys that go up on either side of the house that supply the venting for the 9 fireplaces that are in the house. And again, we'll go upstairs at some point and give you a tour of what's going on there. But yeah, this is what we've got here. So you can see it's all earth formed, and we were so graciously left a bunch of canning jars. It's hard to see, but there's a giant foundation wall for the foundation footing for the actual chimney on the east side of the property. Now look at the earth form. I'm assuming this is all hand dug. We've got some, some falling here from the moisture. This soil is so saturated. It's amazing how it holds the water. But we're going to do footings right about here, one footing here, a footing here, and a footing there. And then we've got around the back, we're going to do the same thing. By the entry, there's one steel post that's kind of dangling. There's a lolly column here at some point, and you can see it just was not done correctly. 4x4 post holding up, a giant 2-3-story building, and the attic goes up even farther, full attic space. That's an incredible amount of dead load that these little tiny sticks, toothpick holders are thinking that they would hold. But it was an attempt to get this done, and it certainly helped it along the way. But some of these big timbers, these oak timbers, there's one hand hewn beam in here, as you can see. Right up here, this is the hand hewn beam that we're going to actually get a better view of it there. That we're actually going to put the main shoring, and that seems to be the main bearing wall that goes up into the second floor and supports the floor up there that's been sagging. So let's get to it. Set the camera down, and we'll do a little digging and reconfiguring. And check this out. Check this beam out here. This has got a slight bit of a skew to it, and believe it or not, it looks like it just warped over time. Someone put that lolly column there. There probably was a wooden column there to hold this massive, probably 30-foot long, looks to be maybe a 4x12 or better beam that supports, perpendicular to the existing joist, which is a good idea. And that was put in some, I don't know how many years ago, 100 or so years ago. May have been done when the house was built, I'm not sure, but we'll get into that. Okay, what we've got here, we've got this big beam, looks to be an 8x12 hand hewn beam. And what we're going to do is take our plumb bob here, and we're going to plumb down points at third points along here, which is somewhere around 6 feet center, and then another 6 feet from that end. And that'll give us a good span to allow this beam to recover from its decades of deflection. So I've got this plumb bob. We're going to plumb down toward the center, and then make a mark on the floor, on the dirt, I should say. Make a mark on the dirt. Center line of the beam down to the floor, and I'll get a mark. I'll make a little mark with the end of the plumb bob. I mean, you can do this with a level, I'm sure. There's other clever ways of doing it, but the problem with a lever, problem with a level is that you've got to go in 2 dimensions at one time. And the neat thing about the plumb bob is it does the 2 dimensions hang straight, and then you put a little dot where the plumb bob is going to give you the location. But first I've got to measure the distance across here, get it at third point so I can get 3 stable footings here, and 3 stable footings, and then we'll put the shoring material up after that. Okay, we've got our plumb bob here. We're going to pick our mark. I marked 8 feet. We got 3/8. That will give us 24 feet span to the inside dimension. So this will give the plumb bob here. That's the spot right there. Keep an eyeball on it, and you can take your marking paint, and there's their spot there. I'll go over this one. Do the same thing here. Set that down. Mark. I marked the center of the beam, marked it at 8 feet from the other one. I'm going to do 3 footings across here, and I'll cut that span down to 8 feet each. And the plumb bob. Right there. You make a little mark, and then keep your eyeball on it. It's probably easy to do. You have somebody here to help you. and that one there, and so on. I don't know if you can see this side. We're going to put this one up out of the screen. I'm going to put another one at the other end, but it's kind of out of screen. I guess I should show you where the plumb bob is. Most people don't know, but it's a little brass used as a pendulum. This happens to be a Dietz. It's an old one. I've had it forever. To be maybe a 6-ounce plumb bob, and I don't know if you can see it there, but yeah, it's just a little brass instrument, and then you tie a string to it. You can use almost anything. I mean, prior to this, they used you know, a stone with a string on it or something like that. You don't have to get one of these, but just so happens I had this for a long time and it works well. That's what a plumb bob is. Most people don't know what that is. Okay, we've got our 3 footings set, dug. 1, 2, and another one over there. Found a bunch of rocks. Except we're not going to move those rocks, but that'll be more than efficient to support that one beam. And that beam happens to be right in the center where the stair run goes up. On the right side, it's actually a bearing wall. It goes from the first floor, the basement, actually from these columns, to the first floor, and then from the first floor is a wall that runs to the right of the stairs going up, and that is a bearing surface, so that'll be a good support right there for those. Okay, here you've got the same scenario. They have a little 4x4 here with no jack or nothing, but it's got the 8x12 support, and you can see this material just disintegrated. But it's bearing on the foundation, the dry set foundation for the fireplace, and what we'll do is put another support here, another footing right in this corner, and support this part where it's coming up on the ledger beam on the perimeter, you know, the sill beam. But actually, it would probably be better to put it over here, to tell you the truth. Yeah, because this looks like it's got a pretty good bearing surface over here, but over here this is kind of sketchy. This 4x4, it's sitting on a piece of stone. So I'm going to actually put it. I'm going to put the footing like right in this corner here. We're going to put another footing here with this crazy splayed structural beam. It's kind of wonky right here, so we're going to put another footing right there, and I'll put another post toward the end, you know, right up in here. And the footings, I think the question may come up is, you know, why these footings aren't being compacted with soil underneath. Well, what we've got is this is in situ soil. I mean, if we're assuming a bearing capacity of the soil is about 2,500 psi, without compaction, it's in situ. This is so far down into the earth, there's really no need to, you know, compact it. You could get a flat plate compactor down here, but I don't want to, you know, destroy the integrity of what we already have, and these walls that are already collapsing with the water infiltration through the foundation. But a lot of this is going to get cleaned up. I'll pull a lot of this soil out of here, get some people in here, put a lot of these foundation stones back up where they're supposed to be. Maybe put another, you know, maybe a retaining wall of some sort there. I'm not sure how I'm going to tackle this corner over here yet. But yeah, that's the question I thought when I was digging this, scraping this footing out. This is in situ soil, meaning it's in place. Assuming the bearing capacity is about 2,500 psi, and with this design of this footing, you know, 24 by 24 with the rebar, we'll be good. It'll be fine. Okay, what we're going to do here, we're going to stake it out a little bit, and just to hold it from floating up, because the hydrostatic pressure of the concrete will float it up. People don't realize it. It just won't sit there by itself. And another thing, this is we made a mat of rebar. We got number 4 bar going each way, about 6 inches. And again, these are only 18 inches wide. Allow clear cover 3 inches, so you don't have water infiltration into the through the concrete, and then end up spalling the concrete because these start rusting. They start rusting and they'll pop out. But this is a number 4 bar. And what a 4 bar is, everything is the rebar is predicated on 1/8 of an inch. So 4 is a 4/8 of an inch, which is actually half an inch. So if you have a 5 bar, it's 5/8 of an inch. but these are 4s, which is a ½ inch. 4/8 is 1/2, so it gives you a number 4 bar, ½ inch. Perfect. We're going to stake those out and then see what happens. Okay, we're going to stake the stakes that I put in there, we're going to stake them down. We're going to use these duplex nails. You see they have a double head on them, and the duplex nails allows the, here, put it against my shirt, but the duplex nails allows you to nail it in. It grips the wood against this first little ring. The second ring is when you strip the form, you can pull it out and not have to dig up the wood or try to get in there with a cat's paw or something. And I don't know if I mentioned before either about the in situ soil. In situ means in place, not disturbed. This is not filled. This is dug out. This is the soil. If you keep going down, it's in situ until you know, the China, whatever. But yeah, none of this soil under here is disturbed. Of course, the caved in area, of course, is disturbed. That would be removed if you're going to put a footing over there where it's already caved in. But this one I'm standing on and everything else is existing rock here. A lot of stuff that's still all existing. We're going to nail and level the form edges with the duplex nails, and that'll hold it in place while we pour. Hello, welcome to this historic home. If you hear a little inspirational music in the background, that's Johann Sebastian Bach. It's the best stuff to work by. So let's go down to the basement and see what we've got to work with those shore posts. Okay, here I have to cut the form back. I don't much like three-sided forms. It just puts too much pressure on the other side of the form. We're not talking about a lot of weight here. I mean, as far as hydrostatic pressure from the concrete, but that's what was plumbed in before. So what I'll do is just set some stakes down to keep the sides from blowing out or splaying, and that'll be perfect. And I'll replace this once that cures. I'll replace it, take this out, and put the new column right there. Here you can see I've got the other ones in place. Same story, shore jack on top, screw jack on top on the footings that we poured a few days ago, and they're cured good enough for now. I'm going to wait a good 7-14 days before putting substantial load on it. But this one over here could be problematic. This actually existing beam, it's like a 4x12 oak beam. It's got a little bit of a, if you can see that, it's a little askew, a little twist to it, and we're going to convince that back vertical to the floor with the method I've got in mind here. Same stuff here. Let me get the screw jack. Here we go. Just nail that on there. I got bent nails. It doesn't matter. That's what I used to do as a kid, is straighten nails out. There's like a brand new nail. No sense throwing that out. Some guys I used to drive them crazy. They'd say, "You're a cheap guy." And my Latin friends called me. He said, "You walk on your elbows." I said, "Why is that?" "Because it saves the soles of your shoes." Oh my goodness, my old friend Elias. Anyway, he worked for me for 25 some odd years, and he would always kid me how cheap I was. But hey, you know what? That's the best way to be. If you're always trying to save money and you got support a family and everything else, there's no other way around it. Think of even those little things, the big things. Anyway, let me turn the camera around and we'll go over to that little cubby over there and put this in place. All right, I'm going to sneak this one right in between the dry set foundation for the chimney. This is the east opposing chimney, and that's the foundation for it. What we're looking at here. I knew I had one that was stuck. There. There was one that just would not turn for the life of it. All right. Get rid of this crazy one here. There's some neat stuff back here underneath the on top of this. I'm going to turn the camera a little bit. You'll see once I get done with this, there's some old bottles. And I never had a light back in here to see what they were. But someone stashed their laudanum bottles or some kind of medicinal things. Just tossed them up in the rafter. They were tossed them up on top of the foundation. Boy, how does that look? Terrible? Yeah, probably. I'll get a level on here in a minute. There. Whew. Okay. Let's see. Now we're looking this way. Let's see. How do I go? That way. Keep it untwisted. Probably the side I got to worry about. Yeah, well. Oh. I don't much care for banging on the steel. Sometimes best just use an arm and a hammer. But that doesn't get it all the time. That's good that way, and that's looking good that way. All right, I'll put a little tension on it. Which way? Okay, that way. I gotta get a couple nails. Oh look, an old formwork nail. That's perfect. That'll work just great. Oh. Get out of the way. We can find another one. Oh, back in a minute. I'll find another. Get another nail. It looks like a new nail. Oh no, I gotta use a new nail. Okay, that's cool. Uh-oh. Sparks. There we go. Let's put some tension on this sucker. And what I'll do is I'll get a piece of conduit or an old cast iron steel pipe and put it on the end of that. Get some leverage rather than hitting it with this thing. I don't want to bend this. But put a cast iron pipe on there. A couple feet, get a lot more leverage. There. That's pretty solid. Again, what I'll do too, I got a 50-ton jack. I made some dunnage. I made a mud sill, which is a stack of little sandwich. I call it a Wendy's triple burger or something, where you got plywood, opposite direction, 2x6s, a layer of those, and another layer of plywood, 2x6s in the opposite direction, another layer of plywood. And the plywood ends up being in opposite directions as well. Another point, other people don't realize that plywood is always odd layers of laminate, because it's strong in one direction and weak in the other. In the short direction of a 4-foot sheet, that's the weak direction. In the 8-foot direction, that's the strong direction, because you've got the striations of the outer layers in the same direction on the very outside, but the other ones alternate as they go up. So same kind of thing I'm doing with my mud sill. So when I put the 50-ton jack on it, it'll get a pretty good, that load will spread over a 2-foot by 4-foot square foot area, 2x2 area. And you know, that shouldn't push any of this in situ soil down. It should be just fine. All right, let's see if we get back in here without stepping in something or whatever. As promised, let's see what we've got back here. Oh boy. Hold it. There, this tripod up. Yeah, buddy. Look at that. You never know what you're gonna find. Look at all those bottles in there. I don't know what that white thing is over there. There's lots of bottles in there. All kinds of stuff. Wow. This historic home, always up for surprises. Got a little bit of a cave in here. It's kind of indicative of the North Carolina soil. It's just like slides. It's like just a pile of marbles. I don't know why it does that, but anyway, well, I do know why it does. It's high silica sand. But anyway, we've got a lot of cool bottles, which we'll get later. I don't know what that white is. I hope it's not a snake egg or something. Yeah, there's some cool stuff in there. Add to the collection. I'm surprised they weren't ganked by the people that looked at the house. The realtors that bought all the, not the realtors, the antique dealers that bought all the furniture out of it. I'm surprised they didn't get their little grubby fingers on that, but they didn't. I'll put my grubby fingers on it and add to the collection. Yes. Okay, what we're going to do next is run a string line. I think you can barely see that. From as far as I can go to the left of that main support beam, I'm going to run the string line all the way across the face. We're going to drop it down right on the corner as well as we can. We got some things we need to get rid of, but I'm going to run that string line all the way over. Let me get a better shot here. That string line is going to go, where is it? It's going to go right. There, what I've got is one end of the beam to the other. It looks to be about an inch deflection in the center, but it's much more of that upstairs if you look at the whole overall deflection. But anyway, I'm going to put a nail right here at the bottom of the string. Actually, I'm going to put a nail. I put a nail at the very top of the string, and so when the beam eventually raises, rather than putting a mark, the mark might go away. This duplex nail is just barely touching the string. Really touching the string. So when this goes up, I'll know how far the nail is from the string. You know, so if this goes up, the string will depart from the nail, like hopefully an inch or so. But again, it's going to be over time. Yeah, that's what that is. Okay, I've got my 4x4 here, and you know, I was thinking on the way down here, you know, like some people say, oh, why don't you take that beam out of there and put a new one in? Well, this beam actually is probably 25, from this point to the back, it's probably 25 feet. It supports probably 10 these floor joists, and you take that out and do it. Well, that's why I probably survived from business from in the construction industry and engineering for the past 44 years, because I found creative, economical ways of fixing things, and especially in house restoration. You've got to utilize what's there. You're not going to make it all right. I remember doing a house one time and a lady said, "Oh, this floor, put a marble on it, rolls away." I said, we can stop the slope and bring it up. But in order to bring this up, it was a frame stucco house, so you had stucco on the exterior of the house. In order to fix that slight indentation or slight slope in the floor, we'd have to almost disassemble the entire house on the one south side, because you can't jack stucco. Stucco will crack, and then you have to replace the lath and the whole framing. It's a whole mess. I mean, the house has been that way. It's taken decades to get that way. So we can stop it. We can prevent any more damage from happening. But to replace that beam, it would be ludicrous. I mean, it would just be totally cost prohibitive to have to shore up each one of these. It's done. It was done, I don't know how many decades ago. This is probably done over 100 years ago. Of course, with Wally Collins, probably 30. But there's no sense taking the entire thing out and reinventing the wheel and spending money where you don't really need to spend money. Anyway, so this I got the 4x4. It's resting against the footing there, and let's see what we've got to get a vertical on it, and I can get my dimension of the horizontal piece of my audacious fingers out of the way so I can see the plumb bob. The bubble on the level, and I'm going to measure it up here. Plumb. About 7 inches. We'll get 7 inches from there. I'll cut myself a block, and then a horizontal 4x4 piece. And except this, it doesn't tumble over on my head. Look at that. You can see the old cut nails on here. Here's some old nails. They used to stamp these nails like pre-1800. A lot of these nails were stamped to a big giant stamping machine, but they had no way of incorporating a head manufacturing tool in the stamping machine, so they had a little handheld strap of metal, and it had a rectangular indentation on it. And they would take each nail, put it in a vise, put the little rectangular die on there, and smack the top of the nail. These were so soft, it didn't take much. They'd smack the top, and that would mushroom the top of the nail out, and you'd have the that's how they would make the nail head. But they would stamp the nail. You can also tell that. You can see a little ridge on the edge of the nail. Unlike a rosehead nail, which is actually a rosehead nail is handmade, whereas a stamped cut nail is dyed by machine, and the head is made by hand.